to make some noise for the people in the expo zone would know that we're starting. So please note that we have a substitute teacher, Stas, who was supposed to talk about 1,000 APIs. He's stuck in Dubai because of the flood. And it's good that we have Eran here. He can be the substitute speaker. He's been writing code all his life. The life is long. You can judge by the gray hair. It's close to mine. So we continue our talk about using Kubernetes everywhere. So please welcome Eran, please.
One. Okay. Okay. So first of all, let's start with a small survey. How many people here knowing what is Kubernetes? Not everyone. Okay. Interesting. You're coming to a lecture in Kubernetes and you don't know what is Kubernetes. Okay, let's go to the second question. How many people here running Kubernetes in production? Okay, nice number. And the last one, how many people here, or developers, really running in Kubernetes or developing with Kubernetes? Okay, so what? All the other are more infrastructure guy or DevOps guy? Okay, let's see. So let's start a little bit about myself. I am like 15 years in the market, starting from more software developer career, I can say. 15 years ago, I started with C#. I don't want to be ashamed on it, but whatever. And then after a few years like developers and architect, whatever, I getting more into the DevOps field, cloud architect, and Kubernetes especially. I found Kubernetes more interesting from time to time. I can say that, originally Kubernetes is like Google product, and the more you get deeply into it, you see how much engineering they put inside and whatever. So nowadays, I just moved the beginning of the year to Cyprus, and I opened a Cyprus company, like consulting, doing freelancers in DevOps, cloud, all over. That's a little bit about myself. So let's start with some introduction on Kubernetes development and cloud service integration. So a lot of years, there are, like I say, a lot of opportunities to work locally with Kubernetes. And for sure, we know the importance of having things, running locally. You can debug them locally. You don't really need the cost of the cloud. And you can run it in your own laptop. And also, you don't really depend of how complicated the network in the EKS, in AWS, or whatever cloud provider you're using, or other Kubernetes distribution. So we can work locally, and it's very easy and I could say simple. We have a lot of option to work locally with Kubernetes. I will mention a few of them, but I think the most popular from all of them. First of all is Kind. I don't know how many people are familiar with Kind? Not so many. It's not so familiar tool, but it's also like a local Kubernetes. I can say that all the world of local Kubernetes was very improved by all the IoT market, because if you work in IoT, you want to run something locally, edge computing, or maybe also IoT. So you want something to run locally. So there are many tools that get improvement because of IoT becoming very hot thing in the market. Also, another one is Q3S. It's also using more on the IoT things, but probably many of you know minkube. Yeah, how many know minkube? Yeah, minkube is the most popular of them, I can say, running locally. I also, I think, work with minkube for at least 7 years or 8 years, and I seeing some improvements from time to time, that they're doing some improvement in developing this tool. I can say that still it doesn't have its own, capabilities to working locally. It's not really like working in real cluster, but it's probably the most popular tool for work locally in Kubernetes, and you can do a lot of things that you can do in, for example, EKS if you're running in AWS, and you can do it everything locally, like you say, everything locally, no network issues. You can have maybe real fast feedback and so on. So yeah, people or developer often, I can say, or usually use minikube. But let's start from some challenges of running Kubernetes cluster locally. For example, we have like 30 or 50 services to run locally. Yeah. Maybe some of our service also, heavy consumer of resources like CPU or memory. And, like average laptop, also for the average developer, doesn't have many, I don't know, maybe 16 gig RAM or not so many resources. So having it running locally, and I have to say from my experience also 30 or 30 services, it's not so many. You can find companies that are running thousands of them. So running it locally is kind of challenging, especially if in consuming the resource like for the local laptop. Our laptop also hardware is not enough to run this amount of services. There are, or I can say I have colleagues that for that one maybe try to have better hardware, but I think that you can always maybe get a better one, but there is a limit for the local, I can say your local laptop or your own laptop, in a matter of prices or whatever. Also, usually we don't have really like a simple 2 or 3 services that speaking only with themselves internally or something like that. Usually we have like architecture that we need to talk about with other cloud services like RDS, SQS, LAMBDA. Yeah, that's either the the list of the AWS one, but you can choose whatever cloud provider or other third-party services that you want to work. And the question is, how can we mock it locally? Yeah, how we can really have the experience locally instead of working, in the EKS, in the cloud. I don't know whether there are a local stack or other solutions, especially in Amazon. Also, from my experience, local stack is also have its own restriction, and it's also have its own limitation to working locally. And also, probably we want, to work closely enough to the real, I can say, environment that's running on the cloud. And running it locally also with local stack, it's kind of not usually the same like running in the cloud. If we have also complex architecture in the cloud, but I saw also companies that have architecture outside the cloud, and they want to work with all these services. And that's the question, how we can do it locally. How we can really have a complex architecture of our infrastructure that we need to have the experience like running it locally. And the next question is, how can I debug with my favorite IDE? So meaning that I want to really have experience like working locally with my favorite IDE, with Visual Code, IntelliJ all over. I don't doing PR to one of them, but I'm, like developers, we want to work with our favorite IDE and to really feel that we can work like locally and smoothly. So let's start with kind of a little bit introduction to mirror-d and Telepresence. And the main advantage of using these tools. So the main point here of both of them, that you can run locally in your code editor. So you're running like locally the context of your Kubernetes cluster. So you really feel like, especially in network view, like you're running it locally. Yeah, like you're running it locally. You're working with a remote Kubernetes cluster. For example, let's take AWS like EKS one. Yeah, but you really feel like working locally, and we will explain it later more deeply. You can run service locally with your own favorite IDE, and also with other tools that may be running in Amazon or in AWS, but you still feel like you have like a local network, and you don't really, experience the latency or maybe other challenging working on the cloud. Like we talked before, we don't really care in that thing about what the resource locally you have, how many memory, how many CPU or other resource that you have on your laptop. And you just, focused on your own development process. And the main point here that you can get like very fast local loop, with no waiting to container yet to build, push, and deploy, meaning that usually We get used to all the CI/CD pipeline, Jenkins, whatever, you name it. But here you can work locally without waiting for Docker images to build, Docker images to push, Docker images to run, whatever, container to run where I want, like in which cluster or whatever. I'm working like locally, I'm feeling it locally, I experience like locally. And yeah, I got very fast loop with my developing process. So Telepresence is the first tool to talk. How many people familiar with Telepresence here? I just want to understand. Not so many. Okay. So a few words like in general about Telepresence. Telepresence is in CF project. It's nowadays or created like originally by a company that called Ambassador Labs. Nowadays they have also the commercial versions that we will talk about it later. And it's probably, I think, tool for at least almost 10 years in the industry. Like I remember the beginning of it. It's a very well known in all the local development side. We will speak more deeply about it later. And the second one is MirrorD. You see there's a logo also for MirrorD. MirrorD is produced by a company that called Metal Beer. It's a new one, like it's almost, I think, year and a half. It's an Israeli startup company that found or developed this tool, and we will see a little bit deeply also about it later. So let's start from Telepresence more deep dive. So you see here like a big picture architecture of how Telepresence work. So we can see from the left side that we have like a local services, a laptop or something like that we're working on. I am working on my own laptop, and I have my own client of Telepresence. I just install the CLI of Telepresence. And then they will see, first of all, we're going through Traffic Manager and Traffic Engine. This is a two part of Telepresence that really install or sitting in the cloud or cluster part of the picture. So the Traffic Manager is more like a general, I can say, something that you need to install in order to having Telepresence working in your cluster. And then you have the traffic engine that really having or living behind the real pod that you want to intercept. So in general, what it will do, yeah, you go from the, let's see if it works. No, okay. Whatever. You go from your laptop. First of all, you go into the traffic manager, that it manages the traffic in general, and then he can set your traffic to go to the specific traffic agent that you work with. You want to work with, like leaving more of that. In the same pod like the application container. I think that in general we can say that it's very close to working with Istio, for example. Yeah, like how many know Istio here? Okay, so Istio have a proxy, envoy proxy inside every pod. that we enable Istio. So yeah, a real container, and then like Istio is the network proxy to everything. So it's almost like Istio sitting inside the pod and getting all the traffic from the traffic manager. And then if we really want to intercept this container, this app container, so it gives us all the network to our local laptop. And then, you know, I feel like really working locally. Like the cluster is, for example, sitting in EKS, but I'm having, for example, if my service expose port 50 or 5050, so locally I can work to 5050 and can have a response or whatever. So the experience is really working locally, but we work with remote cluster. We work with EKS, for example. The main, I think, point that I want to emphasize here that you see that we need something to be permanent install in the cluster side, the traffic manager, and also the traffic agents that working in the same pod. And I will later emphasize it, especially working about mirror D. But here you have something permanent that's sitting inside the cluster. So the main feature of Telepresence is I have to say that Telepresence, it's in general very simple tool, and is doing what he needs to do. So we will talk about the main feature, the two major one that usually work with Telepresence, the intercept and preview URL. So the intercept one is like the usual, I can say, feature that everyone that's using Telepresence working with. You working in your laptop, and you can get all the traffic from the remote cluster to your laptop. It's bi-direction port forward, so you're doing port forward from all your local to the remote and the other way. So you can feel like working locally, but still you're working with a remote cluster. That is the intercept part, the simple and very famous feature in Telepresence. Yeah, you run Telepresence intercept, and you get the intercept to some specific service or whatever, or all the cloud. It's also kind of something that you can configure which service or which part of the cloud, if it's on only one namespace or whatever you want to work with, but you just intercept the traffic from the remote cluster to your local laptop, and you can work locally and have experience like working locally with your own IDE or whatever. The second one that called preview URL or preview routing, it's kind of more complicated feature than the simple intersect. What we have here what they call preview URL, that you can have people, like especially to have, for example, you see here's the QA. They have a specific URL that they can work with it, and they can have specific URL, for example, to the agent or specific service, but all over the normal URL is different. So they can work like with specific feature, that we want, for example, QA to check, but we still want that all the cluster will be in with another version. So we get the preview URL, and then they will see, for example, version 2, but all other that using the normal URL, we will see the previous one, the version 1 that's running in production. And in that case, we can have URL or checking some other version of our software locally. Like you know, we're still finning locally, but here we can play with version. We can play with maybe we want to disable some feature, to enable some feature, and so on. So this is kind of also feature to Telepresence to have more, I don't know, it's so complicated, but to have more option to work locally, but not like straightforward with, I having my own laptop working with services, and it's straightforward bi-directional network, but it's still very, I could say, one stupid thing to do. Here is kind of more complicated. So this is a main feature of Telepresence. And let's speak a little bit also about mirror D. So mirror D, like you see here, is also something that can run locally in your laptop. But if you compare it to Telepresence, here you see that we have kind of sidecar that's running with the app container, but there is nothing permanent that really sitting in the cluster. Only if I really run my mirror D locally, then in real time, it creates something in the pod inside our remote cluster, and I can work with the traffic there. It's not something that is really sitting permanently in the cluster. And also, from more, I can say, technical perspective, it's more efficient being listening to more low-level ports in the Linux kernel, and that's the way it works like behind the scenes. And because of that, it's kind of more efficient, I can say, to work with more than Telepresence that only just installing inside of our pod and getting, like I said, like a proxy over network, but doesn't really do it efficiently from more Linux low-level infrastructure. And also talking about mirror D, I think the main feature or the thing that we want to speak about it is intercepting vs mirroring, meaning that Telepresence is doing intercepting, is just taking the remote network to our local laptop. So it just like doing like more or less than port forwarding, yeah? It's just taking the network from one side to another side, but the main thing of mirror D is doing mirroring. It's meaning that both sides, I really have network up and running. So I don't doing like port forwarding. Both sides have network up and running, and I'm mirroring the network from the remote to my local laptop. Yeah, that's a point that we really need to emphasize here. Yeah, and here we have like a small table of compression between them, between Telepresence and mirror-d. Let's go over the main one. Yeah, we see that Telepresence requires the root access on your machine. That's the point what we say, that it's still really something permanent in the cluster, and because of that, we need a root access to your machine. Also, there is permanent deployment running in the cluster. Also, I think a good advantage to mirror-d that nothing installed in your cluster. Like we talk about traffic mirroring, and so Telepresence doesn't really support traffic mirroring, that comparing it to a mirror-d that support traffic mirroring and interception. And the point here that it's really Telepresence really connect your entire machine to the cluster, vs like mirror-d, that you can do it more granularly, that you can configure it more to more specific one. I don't want really to have all the cluster locally. Both of them have open source version and commercial. I don't want to really get into it like more deeply, but in general, both of them have what they called like a team version, working in a team, and this is a commercial version. And then you have maybe more features, more SaaS version, more support, so on. But the basic features that we talk about, both of them are supported in the open source version as well. So you can have the commercial one, but the open source is also good or enough for me. Yeah, so like just a small summary of what we see. So we see that working locally with Kubernetes cluster, like minkube, the famous one, or something else, is very widespread in the market. But you can maybe work like, one service, two service, maybe 10. But more than 10, I think it's really challenging to working locally in your own average laptop. Having also, network with all other services running in the cloud, whatever. So we really have an opportunity to use tools that giving us the experience like working locally, but not having the real cluster locally, like Telepresence, mirror-d. Telepresence is a historical, or the first one that giving us this ability, and the mirror-d is the second one that it's pretty new, but I think have better capabilities than Telepresence, and most efficient than the Telepresence one. A few thoughts about like all this topic. I think that from time to time, when Kubernetes is being the mainstream in the industry, so having developer experience is very critical here. And I saw from time to time a lot of companies are taking it into consideration, not only from the network view, like we talk about, working locally with some other services in the cloud, for example, and feeling like local network, but you can find it in another areas like doing CI/CD maybe locally, or having other development experience like working locally. And I think that from like in the future, because Kubernetes will be more widespread, and so probably we will see more tools in this field. That's in general, and now it's a QA. Yeah.
Thank you, Eran. Please ask your questions. I was about to say, speak now or be quiet forever, but we have a question.
Thank you, Eran, for your presentation. I'm Alexander from XM Platform team. I have a couple of questions, actually. The first is, maybe I didn't get it from our presentation. If our local service need access to some private database like RDS or something like that, not for the connection to the servers inside the Kubernetes, do these tools help us with this? I mean, maybe some proxy for calls through the Kubernetes to some RDS, for example, or something like that.
Yeah, so, it's very depends on the specific use case, but in general, you can, that's also the benefit here. So you can work with other cloud services, like you say RDS or whatever, but having it like locally. For example, if your MySQL is like port 3006 or whatever, so you feel like you're working locally. You don't feel like, working in RDS in the cloud.
No, I want in the cloud.
Sorry?
I want in the cloud. For example, I already have a database in the cloud. The rest of my microservice architecture right in the Kubernetes. And only one service what I'm deploying, what I work on it, on my local machine.
Yeah.
I want to connect my small service and local machine to all services inside the Kubernetes, and these tools can help me with that, right?
Yeah.
And I also want to connect my service to RDS inside, what they behind.
So for example, I can say a simple solution would be, if you work in the cloud, and in your EKS, and you have the real, permissions or network or whatever to the RDS, so it's the same like working locally, because it's really a tunneling your EKS network to a local one. If you want more complicated things, that only the local can get to there, so it depends on the specific use case. But in general, I think that if you work in EKS, for example, and you have all the permission and all the network to the RDS, it will be similar.
Okay, thank you. And another question, there is another project which called is DevSpace. We are trying to test it in our environment. Do you know about this DevSpace?
I hear the name, but
okay, it's quite similar. Yes, maybe I just want. If you made some research, maybe you just avoid this project, and I didn't get which one you choose to your environment, MirrorD or Telepresence.
So I have a lot of experience with Telepresence, but MirrorD, from my experience, it's better.
Telepresence. So
I'm saying MirrorD is better.
MirrorD.
Yeah, it's better. It's very new, so it's a startup company. Let's see what they get in the future. But probably it's better for me. I know that the last KubeCon, if you want to see online, they have a good lecture in YouTube, last KubeCon in Paris, that someone from there really explained very deeply how it works. So I really recommended this lecture.
Okay, good. Thank you so much.
Welcome.
Thank you. I have some information for you. So to those of you who scanned the QR code and answered the questions on DevOps and development on the XM booth, before the final talk, they will make the draw and figure out who's lucky. So in 15, 20 minutes, check them out. Any other questions, please? It only means that Eran, you can proceed to the discussion zone, which is right out the door, and then maybe there will be more questions without the microphone. Thank you very much for your talk. And have a good evening, guys. We have 20, 25 minutes till the final talk, and then the after party.